Hello everyone, welcome back. So this time we're going over the concept of the center of gravity. Now, what do I mean? Well, let's find out. Okay, let's get all these in here. There you go. So, first off, we know we have this body of some crazy shape. When things are simple, like when we have a box, okay, for a box, it's at the center of the box. For a sphere, the center of gravity is at the center. That's what the center means here. But things aren't always that simple. Sometimes you got some crazy shape. Like, for example, let's say you had something that looks more like this, okay. Where's the center of gravity for that? I don't know. And there's no equation for this. You can't just find the center of gravity being like, oh, it's at the center or it's a third of the way from the base. Remember those from some of your geometry classes. In this case, you don't have any idea. So what you do is you say, okay, we've done calculus. We know calculus. So let's look at this from calculus. So we break it up into all these little rectangles. A bunch of little rectangles. Now each of those little rectangles are boxes since it's three-dimensional. We know where the center of gravity is for that little box. It's at the center of it. And so we can then integrate to figure out, okay, where is the center of gravity based on more or less like a weighted average of my entire part. Now, the center of gravity is simply a point where we can act like all the force acts at that point, all the weight acts at that point. This is the resultant of all the weight from all these individual little particles. So, another thing we can learn from this is the definition of result force, the sum of moments due to the individual particle weights about any point is the same as the moment due to the resultant weight located at G. And finally, one last really key detail. We have all these little forces right here, and you might be thinking, okay, if I'm doing it around G, what's the sum of moments? It's 0. As long as you take the sum of moments around the center of gravity, then it's 0, according to the weight. And that makes a lot of sense, because if we have a bar, center of gravity is at the center of that bar. If I take the sum of moments around this point, one force, its line of action goes through that point, no moment. Take the moments around here, there's a moment. So you've seen all of these things before. You just haven't necessarily used them in problems. Okay, now this is all fine and dandy, but you're not going to be like chopping up every little device into little boxes and weighing them each individually. So how are we actually going to do this? Well, we can do it by having a few simple equations. So first off, let's say that we have, we have this elemental weight right here, dW, and it's located at a point x squiggly hat, y squiggly hat, z squiggly hat. I'm sure these have a fancy name. I've never been able to figure out what it is. If you can figure that out, email me so I can stop calling it squiggly hat. Okay. And so what we do then is we break it up into 3 different directions, x, y, and z, because the moment, this is a moment we have x bar times w, is going to be equal to the integral of all these little elements times dw. So where their centroid is of the element, this little individual element, with respect to some particular point, be careful about that, times their individual elemental weight. And from that, since we already know the full weight, we can then solve for x bar, y bar, and z bar. So this is the equation we get right here. Now, in all honesty, like let's say we're doing this in a 2D case, which becomes the center of gravity becomes like the center of area there. You might think about it this way. I've got 2 parts, okay? I know where the center of gravity, or centroid of a triangle is. I know where the centroid of a box is. And this more or less turns into a weighted average. So if you have a bunch of simple shapes, this will turn into a sum rather than being an integral. But you don't always get that. Sometimes you have to do the integration. And that's where things get really tricky. Okay. Now, question for you might be like, well, centroid, center of mass, center of gravity, they're all the same things, right? No. They can be, but technically the density of your object could change as it goes through. So while in most cases, if you have some sort of nice homogeneous material, or it's all made of the same stuff, the center of gravity, the center of mass, and the centroid would be at the exact same point, right at the, whatever it is, center of that object. For a sphere, it's the center. For a box, it's the center. If the density changes for some reason, like half is silver, half is gold, it's not going to work that way. It's going to be tilted towards the gold. So that's where that's where the difference comes in. The centroid and the center of mass can be different. Okay. Now, hopefully what you realize is that these two equations are more or less the same exact thing. All we've done is remove gravity, because weight is just simply mass times gravity. So it just really depends on what you know. If you know the mass, you can do this. If you know the weight, good. In the English system, we typically give things in pounds, which is force, so weight. In the metric system, we give things in kilograms, so that might be why you get this one right here. But these 2 points would be the same exact point. And it tells you right down here, we can also find the center of volume, area, or length using this as well, because this is just more or less a weighted average. We have some volume, area, or length weighted by its individual distance from a particular point. And then from that we can solve for the center of volume, the center of area, the center of length. So this is an amazing little tool right here to use for the future. And do not forget it. And also remember that if you have a bunch of simple shapes, this can turn into a sum rather than being an integral. Not always, but it's fairly common. Okay. So what is the centroid? Well, you know what? I've gone long enough today. I'll do this one next time. So stop here. Next time we're going to talk about the centroid, which is just the center of the geometry. And we'll figure it out next time. So hope this helped you. I'll see you all later. Bye.